My name is Lian Albanem Sinag.
My name is Fritz Aldripi Degala.
My name is Sil Vincent Lacuata.
LED1 Materials LED Red Arduino Uno breadboard resistor. In this task, we created a simple Arduino circuit that makes an LED blink on and off. The project demonstrates how to control an electronic component using Arduino programming. By adjusting the timing in the code, we can change how fast or slow the LED blinks. LED2 Materials LED Red Arduino Uno breadboard resistor. In this task, we made a simple Arduino circuit where an LED lights up steadily. The goal of this activity is to understand how to power and control an LED using Arduino. The LED remains on because the Arduino continuously sends a high signal to the pin connected to the LED.
LED3 Materials LED Red and Green Arduino Uno breadboard and resistor.
In this task, we created an Arduino circuit that makes LED blinks alternately, similar to the Christmas lights. The project demonstrates how to control multiple LEDs using Arduino programming. By changing the timing and the sequence in the code, the LED lights up in a pattern that look like festive lights. LED4 Materials LED Red Arduino Uno Breadboard Resistor Button.
In this task, we made an Arduino circuit where LED lights up on when a push button is pressed. This activity demonstrates how to use the input button and the output LED components together. It shows how Arduino can respond to users' actions by detecting when the button is pressed. LED5 Materials LED Red Arduino Uno Breadboard and Resistor. In this task, we created an Arduino circuit where LED lights up when we turn a rotor switch or potentiometer. This project demonstrates how Arduino reads analog input signals and controls an output device like LED based on that input. It shows how turning the knob changes LED brightness or turn it on and off. Second lesson, buzzer.
Buzzer 1 Materials Buzzer Arduino Uno Breadboard Button. In this activity, we use an Arduino with a buzzer connected to a breadboard. The buzzer produces sound when it receives a signal from the Arduino. A push button is used as the input. When the button is pressed, it sends a signal to Arduino which activates the buzzer. This project shows how to control a sound output device using a simple input component. It demonstrates the basic concept of using an Arduino to make a buzzer turn on or turn off based on user interaction. Buzzer 2 Materials Buzzer Arduino Uno Breadboard Button. In this setup, the buzzer is connected to Arduino and programmed to produce sound automatically without pressing any button. The Arduino sends signals at time intervals causing the buzzer to turn on and off repeatedly. This makes the sound play in short bursts instead of continuously. The project demonstrates how the Arduino can control a buzzer automatically using program delays or loops, creating a beeping effect instead of one long tone. Buzzer 3 Materials Buzzer Arduino Uno Breadboard. In this project, the buzzer is connected to the Arduino and programmed to turn on turn off automatically at an interval of about 2 seconds. The Arduino sends signal to the buzzer to make sound for 2 seconds and then stop for another 2 seconds, repeating this cycle continuously. This setup demonstrates how timing control works in Arduino using delay commands. It shows the buzzer can be programmed to produce repeating beep pattern without pressing any button. Buzzer 4 Materials Buzzer Arduino Uno Breadboard Resistor. In this setup, the buzzer is connected to Arduino and programmed to produce sound automatically without needing to press any button. Once the Arduino is powered on, it continuously sends signal to the buzzer, making it produce constant sound. This project demonstrates how Arduino can control any output device automatically and continuously. It shows the concept of a loop keeps the buzzer activate as long as the circuit is running or the Arduino remain powered. Buzzer 5. Materials: buzzer, Arduino Uno, breadboard. In this project, the buzzer is connected to the Arduino along with the potentiometer. The potentiometer is used to adjust the buzzer sound frequency. When you turn the knob of the potentiometer, it changes the voltage sent to the Arduino. The Arduino reads this value and changes the pitch or tone of the buzzer. This setup shows how input device like potentiometer can be used to control sound output, demonstrating analog signal control in an Arduino circuit.
Third lesson, 7 segment.
7 segment 1. Materials: 7 segment Arduino Uno breadboard. In this task, we made a simple 7 segment display that shows a single number. 7 segment 2. Materials: 7 segment Arduino Uno breadboard. In this task, we made a simple 7 segment display that counts from 1 to 9. Now we move to the task. This part was a bit challenging because we had to create our own code, so we did some research and helped each other to get it done. Task 1, the first thing we did was place all the materials on the breadboard and arrange them properly. After that, we worked on the coding until it was correct, and then it successfully counted from 9 to 0. Task 2. The first thing we did was place the materials on the breadboard again and fix the code until it was correct. After that, it worked successfully and displayed the letters E and F. We didn't really find it too difficult since we had examples to follow and these things we could copy. We just struggled a bit the test because sometimes the code didn't work correctly. So now, let's move to the flowchart and the circuit diagram. For task 1, in circuit diagram, we just followed what we did in the computer lab. We copied the arrangement and the codes used there. For task 2, we just like the first one we did. We copied the arrangement and the codes that we are used.
We experience and enjoy a lot of things, and we learn so much from this, but we know that there's still a lot more to learn in robotics, like actually building a real robot.